Today's lesson is on data analysis, day 2. We're going to focus on slopes and y-intercepts. Ben's Pizza and Game Center offers a special dine-in family meals to encourage families to eat there. The manager notices a relationship in the number of family meals purchased in a given night and the number of tokens purchased. This is what is the slope of the table. Well, back in Unit 3, we could just do y1 minus y2 over x1 minus x2. But as we learned yesterday, our calculator can take this data and find us the equation of the line, which includes the slope. So we're going to practice doing it that way. So you go to Stat and Edit, and you clear out anything that's in there, and then you type in your data carefully. And messed up. 380. That's why it's always a good idea to double check your data once you've got it typed in. I think I'm good. And then you quit and go to Stat and go over to Edit and down to number 4 and hit Enter, and there's your equation. So my equation would be y equals 29.39x plus 249.77. But it just wants the slope. So the slope, as we know, is always the number that's with the x, so that would be our a value. So that would be 29.39. And so if I'm going to pick from here, I would pick 30. The table shows the average height of a tree and the amount of years it has been growing. Now, this one's tricky. You've got to read this one really carefully. It says, what is the average rate of change in the height of the tree from year 1 to year 5? That's it. It only wants the data from year 1 to year 5. It does not want any of that data. So you got two different options here. You could go old school on it and just find it by hand and do y minus y over x minus x, which is -6 over -4, which would give me a 1.5. Or you could use your calculator, which is totally fine. I think it takes a little bit longer, but absolutely fine. Clear out the data that you have in there and only type in the data from year 1 and year 5. So your L1 is going to be year 1 and year 5. And your L2 are your Y's, which is 3 and 9. And as you can see, I want the slope because the average rate of change. So that would be my A value, which is 1.5. So either way, you get the same answer. The kicker here is just to remember that it's just year 1 to year 5, so do not type in all of the data. Only type in year 1 and year 5. What is the y-intercept of the line of best fit that represents this table? We cross our fingers and we look for a gift, and there's not one in our chart. So we have to actually find it. And again, back in Unit 3, we could find this by hand. We'd find the slope. We'd take a point, plug it into y equals mx plus b, and find my b. All of that by hand, and we were so good at it. And now we have this fantastic shortcut that can take all of our data and find it for us. Okay. Double check. Looks good. Okay, and again, what is it asking for? And it says that it wants the y-intercept. The y-intercept here would be my b, and b is 0. And then if you think about it, this makes sense because your y-intercept is always your starting point. And think about it. If you work 0 hours, how much are you going to make? You're going to make $0. Joey compared the y-intercept of the graph of the function f of x equals 5x plus 7 to the y-intercept of the graph of the linear function that includes the points in the table below. What is the difference when the y-intercept of f of x is subtracted from the y-intercept of g of x? Okay, so a couple things I need to focus on. Number one, I'm talking about the y-intercepts. Okay, well the y-intercept of f of x is plain as day in front of us. It's that 7. But the y-intercept for g of x is not so plain as day. We have to find it. So the first thing I'm going to do, I'm going to take my calculator and I'm going to go to stat, clear out what's in there, and type in my data. Oh, messed that one. There we go. And then I quit. There's stat, calc, number 4, enter. Okay, so the equation would be y equals 15x plus 5. So g's y-intercept is a 5. Okay, so I've got the whole y-intercept thing, but now what does it want me to do with them? Well, it says difference. And difference means subtract. So normally when it says the difference of f of x and g of x, I would take f of x y-intercept, which is a 7, and subtract g of x's y-intercept, which is a 5, and I would get a 2. And I would pick C, and I would be wrong. Here's why. This says when f of x is subtracted from the y-intercept of g of x. Well, if f of x needs to be subtracted from g of x, then g of x has to go first. So it would actually be 5 minus 7, which is a negative 2. So number 1, find both your equations, and they gave you one, so find the other one and focus on the y-intercepts. And then number 2, figure out who's being subtracted from who. If you see the word subtracted from, then f of x is not going to come first. It's going to come second, and g of x is going to come first. If you don't see the word subtracted from, then you subtract it normal and don't flip anything around. So number 5, what is the difference in the y-intercepts of the following two functions? So, and this is kind of hard to see in this graph, but this is one of my functions. This is f of x, and this is the other function. This is g of x, and I want the difference in the y-intercepts. Now, do you see anything in here about subtracted from? No. So we're going to subtract them without flipping anything around. So I take my calculator and I clear out everything that's in there. Negative 1, 0, 1, 2. Three, 5, 7. Nope. 5, 7, 9. Quit, stat, calc, number 4. So that's y equals 2x plus 5. And then I'm going to do the same thing for g of x. And just to save us some time, I'm just going to tell you that that one's a negative 1.2x plus 0. And that's just from plugging it into our calculator. I'm subtracting the y-intercepts, so that's that and that. There's no subtracted from, so I don't flip anything around. So it's just 5 minus 0, which is 5. A company charges an amount per box and a bulky item shipping fee to ship items that are oversized to a customer. Below is a table showing the number of boxes and the total number of costs of the shipment. So we have number of boxes and we have total cost. Okay, now let's focus again. It says charges an amount per box, that's going to be my slope, and a flat rate bulky item shipping fee. That's my y-intercept. Question says, what is the shipping fee? So yes, I'm going to plug this into my Y1 or my L1 and my L2, and I'm going to get my equation. And so you type all of that in, and you get y equals 0.81x plus 29.7. So the question is, what number does it want? Because here's 81 cents, and here's 29, pretty sure it's supposed to have a 7 on it, And those are both of my numbers. So the kicker here is you've got to figure out which number it wants. And if it wants the flat shipping fee, then it's talking about the y-intercept. So the answer is B. This is the amount per box. That's your slope. The table below shows the number of residents in a neighborhood who received new water meters over several weeks. So I have my L1 and my L2. It says, what was the average increase in residents who received new water meters each week? What was the average increase? So is that a slope or is that a y-intercept? Average increase in residents each week, per week. That's a slope. So I'm going to plug this into my L1, L2, which you can practice on your own. You're going to go stat, calc, down to number 4 and get your equation. And you want the slope, which is 22.7. So feel free to practice that on your calculator. But the plugging it in part is pretty simple at this point. We're just making sure that you're reading the questions and you understand what it's asking for. A company charges an amount per box and a shipping fee to ship items to a customer. Below is a table for showing the number of boxes and the total cost of each shipment. What is the amount per box? Okay, so this is kind of like the other one. We have an amount per box and then we have a flat shipping fee. So the amount per box is going to be the slope. So I'm going to type this into my Y1 and my Y2, and I'm looking for the slope, and it turns out to be $1.19. So again, feel free to type that information in and make sure that you're getting the right data. The table below shows a charge for different number of shirts from an online website. The company charges a cost per shirt and a setup fee per order. What does the y-intercept of the equation of the line of best fit for the data represent? Well, and this is a great lesson in don't just see a table and go straight to your L1, L2 and start typing it in, because actually it's not asking for you to interpret any specific number or find out what any specific number is. It just says, what does the y-intercept represent? Okay, well, let's go back to the problem. It says the table below shows the charge for a different number of shirts from an online website. The company charges a cost per shirt, that's going to be my slope, and a setup fee, that's going to be my y-intercept. And it says, what does the y-intercept of the equation represent? And that's going to be your setup fee. The cost per shirt is your slope. The number of shirts ordered is actually your X value, and nothing in here tells me what the maximum cost of an order is going to be. The table below shows the population of a state in different years. So we've got years since 2005. It's very important to read the titles of your charts. So years since 2005, and it's got our population, which is increasing. So if X is 5, this would be 2010. This would be 2006, because it's years since 2005. What is the meaning of the y-intercept? Well, is it the total population of the city when it was founded? Well, I don't know that because I don't know when it was founded. But my y-intercept here would be when X is 0, so 0 is going to be when it was 2005. I have no idea when the city was founded. The average increase in population each year, that's a slope explanation. And I'm looking for the y-intercept. The total population increase per year, again, that is a slope explanation. And I'm looking for a y-intercept. So it has to be D, but let's look at it. The approximate population in 2005, and that's going to be my starting value. So absolutely, that is my y-intercept. The table below shows the number of people that visited a state park over a period of 4 days. So we've got each day, and we've got the number of people, but this is something that's really important, especially about reading your charts. This is number of people in thousands. So when this says day 1, 5 people, it really means 5,000 people. So day 4, there were 17,000 people here. What is the meaning of the rate of change? Well, rate of change is your slope. So I know that I'm talking about my slope. If you plug this data into your L1 and your L2, your equation becomes y equals 4x plus 1. Okay, so that's a positive slope, and I know that my the number of people attending is increasing. So both of these that say the park had a decrease in attendance are incorrect. I know it's going to be an increase. Then when I get down to pick between C and D, if you don't read carefully, it's very easy to pick D because I can see that my slope is 4. Say, okay, well, it's increasing by 4. But again, I want to remind you how important it is to read even the titles in your charts because this is in thousands. So it's actually, when it says 4, it means 4,000 people. So the answer there is C. So again, not necessarily super difficult, but just making sure that you slow down and read the questions. The table below shows the cost to rent a movie for a different number of days at a movie rental store. What is the meaning of the rate of change? And we know that rate of change is slope. If you L1, L2 this in your calculator, you can tell that your slope is a 1.25. And so the answer is going to be A. The cost to rent a movie increases by $1.25 for each additional day that the movie is rented. That is a slope statement, and it has the correct number. Okay, so we'll just do two more to kind of review everything. The table below shows the average height of a tree and the amount of years that it has been growing. What is the average rate of change in height of the tree from year 10 to year 14? And again, if you're not reading, it's going to be very simple to just go throw this into your calculator and find the slope. If you do that, you're actually going to get a different answer. It only wants the information from year 10 to year 14. So you can L1, L2 this information, but only L1, L2 the 1014 and the 715. Or you can find, this is rate of change, this is slope, you can just find your slope by hand. So 7 minus 15 over 10 minus 14. I think that's much faster than plugging it in, but the kicker there is to read and to make sure that you only use the data that it's telling you to use. The table below shows Aisha's distance from home as she walks from school. So she's at school and she's walking to home. So that's why her distance is getting shorter. She starts out at 5 minutes into it, she's 2.2 miles away from home. And then 25 minutes into it, she's only 6/10 of a mile from home. And it says, what is the meaning of the y-intercept? Well, y-intercept is always your starting value. So Aisha's school is about 2.6 miles away from her home. That's a correct verbiage for a sentence. I don't know if that number's right. But I know it's not B because B says that she walks 4/10 of a mile every 5 minutes. That's a slope kind of statement. Aisha's school is about 1.6 miles away. That would be fine. Again, I just don't know about the number. And then Aisha's school is about 2.2 miles away from home. So A, C, and D are all structured correctly for a y-intercept question. So I need to L1, L2 this and find its actual y-intercept. And so when you plug this in and you look at your B value, it actually turns out to be a 2.6. So the moral of the story for today's lesson is to slow down and read and make sure that you understand what slope means and what y-intercept means. And read, read, read.